everyone! Welcome to Xiaohe Classroom. This section introduces the use of A6 series servo CSP mode in the periodic synchronization position mode. The upper controller completes the position command planning and then sends the planned target position 607AH to the servo driver. In a periodic synchronization manner, the position, speed, and torque controls are completed internally by the servo driver. Unlike the proflip position mode, its trajectory generator is located at the controller end rather than inside the driver. Additional velocity offset or torque offset can be set, mostly used in situations where multi-axis linkage is required. Then let's look at some object dictionaries related to the CSP pattern. The first is the 6040 control word and the 6060 control mode settings. 6060 set 8 is the CSP mode because the position planning in the CSP mode is completed by the PLC. We need to configure the 400 to axis in the software. After adding the axis, the default mode will be the CSP mode. Through 6072, the maximum torque can be limited. And then the position planned by our PLC will be written into 607A little by little, so that the servo can run according to the trajectory planned by our PLC. In this mode, there are some columns of instructions that can be used. 6060 and 6066 parameters. If you don't need additional settings, you don't need to add them. They will have a factory default value of 5 revolutions per minute. If this parameter is added, you must set the value for him. Otherwise, the position deviation will exceed the threshold for a long time after operation. It will alarm. 60B0 to 60B2 are the biases of position, speed, and rotation distance respectively, which can be set as needed. The 6040 one status word can view the current state of the shaft. Then 6064 can view the actual absolute position value. 606C can view the actual speed. And 6077 can view the actual torque. Let's take a look at the specific uses in the software. Right-click Device and select Add Device. Select EtherCAT Master. Then select the added EtherCAT Master and directly search for the name of the drive we connected here. The CSP mode realizes the motion control by adding the CIA for auto access and the plugopen command control access. Modify the name of the lower axis to facilitate use on instructions. Then we first configure the master station in the Properties window of the master station. It is recommended to select the EtherCAT port according to the name, and directly enter the name if one of the EtherCAT port. Then check the automatic restart slave box below. Then add the required PDO parameters in the servo slave properties window. Check expert settings. In the process data interface, a total of 2 sets of PDO are provided, 1 set of outputs, 1 set of inputs, and each set has 4 sets of parameter groups below. For example, the output PDO is selected to be added to the group 1600. As mentioned earlier, the required parameters can be configured into the 1600 parameter group. The addresses with more than 2,000 indices above are the internal parameters of the drive. If you need to access the internal parameters of the drive, you can configure these. Feedback parameters such as status, actual position, and speed can be configured into one AOO groups. Then the configured parameters will be displayed in the I/O map. The CSP mode does not need to directly operate the PDO operation. It is controlled by the plug-open instruction. The instruction can be viewed in the library manager. In addition, you also need to set the type of shaft and parameters such as dimensional conversion on the axis. Configuration interface. Here is the motor resolution. That is, how many pulses does it take for the motor to turn around? The reduction ratio of the China Construction Act. And the last act of the gear outputs the distance traveled by the actual machine once. For example, here, it is set as the motor turns one turn, and the screw goes 10 millimeters. Let's take a look at the instructions in the library manager. In this, single-axis control commands, such as enable, positioning, etc., as well as synchronous motion commands, can be found here. The pin descriptions of each instruction can be viewed here. Most of these instructions are used in CSP mode. Let's write a program to see how they are used. It is important to note that programs related to motion control need to be invoked under the EtherCAT task. Then we write the axis control program. Call the enable command. Read the axis state command and the jog command. Write the axis name here. All are set to 1 here to enable power on. If the output needs to be monitored later, you can assign variables to it. You can use the read axis status command to get the current state of the axis. We're going to use jog commands directly to do the demo. It can be jointed in positive or negative directions. Then write in the speed of jog, acceleration, and deceleration. The units on the command are all application units, not pulses. The speed of writing 10 is converted to pulse units, which is 131,072 pulses second. After writing, download the program into the actual operation and take a look. After the communication is successful, it shows green here. The axis interface can also monitor the position, speed, and status of the current axis. After adding the CIA for O2 axis, the control mode defaults to 8. After it has been successfully enabled, directly trigger the click command to start running. It has run at the speed we set, and the units of the I/O mapping interface are pulses. The data unit monitored by the axis interface is the application unit. That's all. Thanks for watching.